So how do we get the graph of arc sine or inverse sine from the graph of sine? Well, let's draw the graph of sine first. Right? So I've got a little sheet of paper here. I'm going to draw on some axes. I made my x-axis a lot longer than my y-axis. Okay, no big deal there. And let me draw in sine. Okay, got that sine curve going. This is not perfect, but it'll do, right? So we got this here. Let's recall that the period is 2 pi. And so the period is not, or a full cycle is not right there at that first x-intercept after, but rather the second, because we've got an increasing graph, right? So let me mark that right there as 2 pi. 2 pi. Okay. And then, if there's that upper piece and the lower piece, those should be the same size, and halfway between, you would argue is pi. That seems reasonable, right? Just like that. And because it'll be relevant in just a moment, let's, if that's an x-intercept, that's an x-intercept, then halfway across right there, that should be pi over 2. Okay, so let me just kind of step back a little bit and say, so here's, roughly speaking, let's just go ahead and label one more thing. How about the upper y value is 1 and the lower y value is -1. Okay, so kind of running out of room, but I tried to do what I could there. Now, if you take a graph that's properly drawn and you hold in the upper right and the lower left corner, and then you flip diagonally, that is the inverse, except we have a problem here. You'll notice that by flipping like this, the picture does not satisfy the vertical line test. So let's go back. It's because in the original picture, though the vertical line test passes, the horizontal line test fails. So what we actually need to do is fix this by saying, let's not start with sine, but let's just remove just enough of the graph so that the range is still the same. We still want the range to be all the outputs from -1 to 1, right? -1 to 1 on the y-axis. We still want that. So how much of this should we cut? Well, most of it, right? This is periodic. We don't want that repeating behavior because that's going to guarantee the horizontal line test fails. But we want just a portion of this, just enough, cut just enough, but don't cut too much, so that the horizontal line test passes. So let me draw that right underneath. Get some axes again. So I've zoomed in a little more just so that, so sorry, these are not to the same scale here, right? But that point right there is my drawing of that right there. Okay, so let me maybe label this a little bit and then get back to you. Okay, we got right there, pi over 2 and -pi over 2. Okay, let's see how that looks. So I want to compare, again, these look a little stretched funny, but this is just, maybe I'll do one other thing. I'll just draw in big dots so it's a little easier to see. But that portion of the graph has been redrawn over here, kind of blown up a bit. On the x-axis goes at the biggest pi over 2, at the smallest -pi over 2, on the y-axis -1 to 1. So we see that full range, right? The entire set of outputs, or the set of all the y values from -1 to 1, is represented in this picture down here. But so yeah, the full range is represented, but we have just enough so that the horizontal line test passes. Had we included any more of the picture, right, as it starts to dip down, then up there, the horizontal line test would have failed. So now don't look at this picture up here. Just look at this picture down here. In fact, what I'll do, maybe I'll just do that. This is super low budget, right? All right. Okay. So now we take this restricted sine graph, hold in the upper right and the lower left corner. We do this diagonal flip. And what we see here now is the graph of arc sine or inverse sine. So you'll see that now this is the new x-axis, right? What was the y-axis is now the x-axis, or this is the new input axis. Here's the new output axis. For arc sine, let's actually just label, right? So y equals arc sine of x, or y is equal to sine inverse of x. New x-axis, new y-axis. Okay, so here's the standard official notations. Our new x-axis, our new y-axis. You'll see that the x values for arc sine or inverse sine go from -1 to 1. Sorry, that one's tilted. I mean, it's kind of sideways, but it's over here, this way, right? So the inputs go from -1 to 1, and the outputs go from -pi over 2 to pi over 2. This means that sine inverse of anything, sine inverse of any number between -1 and 1, the output the result of applying sine inverse or arc sine always must be an angle between negative pi over 2 radians and positive pi over 2 radians.